Good afternoon, ladies and gentlemen. As introduced, I am from Game Platform Development Office. My name is Kagaya. It's nice to see you all. In this session, the title is Data Processing Behind Line Game Platform, and I'm going to talk about the new game platform for line games that is under development, and also user data processing as well as the design concept and implementation. Without further ado, let me ask you a question. Line games. Have you played line games? Raise your hand if you have. Thank you. It's a pleasure. Yes, in 2012, on November 19th, we started our services, and we have launched many games. And the total download as of February 2016 was more than 640 million downloads, and monthly active user as of January 2016 was more than 30 million. So many people are playing our games. Now, our game business, there are several service models. In various forms, we provide services. For most games, the game development is done by partner companies, and marketing and the operation parts are responsibility of us. And in the development, Line API, our API is actually utilized. And many people have collaborated with us in developing services, and the total number of partners so far that we collaborated with is more than 80, and puzzle games included, casual games included, more than 60 games are being serviced right now around the world. So we have developed and released many different game titles in different genres. Now, for different kinds of games, we're trying to provide services in a stable fashion so that users can enjoy games in a comfortable setting. And Line Game Platform is what we're developing. In other words, we've been providing the platform that provides the basic functions for gaming. Authorization, social graph, such as communication with the Line friends online, and also payments as well as monitoring. These functions are absolute musts as platforms. And there are so many games that we offer, and of course, it's different from one game to another, but most are actually using our platforms. However, when we call it a game platform, it has to be really suited for the games or suited to the needs of the game users, as was mentioned, Microsoft, Azure, or AWS by Amazon. These are leveraging cloud environment, and cloud environment is getting richer and richer. And when you want to develop some service on the web, it's getting much easier to do that. And it is therefore time that we need to have a platform that is really most suited for gaming. And therefore, last year in 2016, we started developing this new gaming platform. Now, this is exactly what we have been developing. This is the new platform. Now, this is the platform for gaming so that games can be enjoyed, and we're providing various functions to enable that. In the interest of time, I cannot cover all the components. However, let's say chat within games, or also bulletin boards in games, and also sharing the video of the gameplay itself, and also guild. When you develop a social game these days, I think these are some of the game-oriented functions that you will want to develop. And in September 2017, this is version 1, and for the games that are developed internally in our game studio, we're really focusing there and doing integration. Then going back to the title of my talk today, Data Processing Behind Line Game Platform. So let me just focus on two aspects. User data handling is the primary focus, and I'd like to talk about the technology there. Now, two functions are review board and guild. These two I will talk about. The review board, I will cover that because I'm responsible primarily for that. And for the second guild, Mr. Zhao is going to speak after me to talk about that. So let me talk about review board. First of all, what sort of functions are there? Now, review board, as you can see in these screenshots, you have a game player, and with regard to objects within games, such as characters and game items, the player can actually make comments or put like, and also evaluate in 5 different levels. And in social games in Japan, in-game games might be limited in number. However, a third-party game portal service can be provided, and that's more often the case. And user reviews, and it would get likes by other people, and the number of likes, and also the user may have looked at or read the article about this, and so these are some of the actions, and there can be a certain character or item ranking as a result of user actions, and also you have to think about the weighting as to the different indicators. Actions or events, what are the weighting that you should use to give scores? And of course, this can be set by the operators or the administrators of the games. And so I'd like to talk about the flexible ranking design and implementation. This is the ranking system chart that simplifies how we do this in review board. The person responsible for the games will actually set the weighting from the GUI tool. This is the screenshot of the actual admin tool that is used. In this particular case, how many times the items were looked at, how many comments were actually written, and how many likes, and how much evaluation or how well it was evaluated, and weighting is applied, and then the final result is the scores that this gets. And the administrator, the operator of the game, can actually set the range or the duration, whether it is going to have slots of 2 hours and maybe the update frequency of 20 minutes, 30 minutes, and so forth. So this administrator tool can be used for setting those things as well. And let me explain the architecture for this function from the top down. User action actually is received by the API server. It receives it from the game client or the game server, and there are certain actions, and there's this event handler that stores that action events. And based on the conditions set beforehand, aggregation service is provided based on certain setups. And there are 3 players that are the primary players, which are on the right-hand side of the diagram, and I'd like to explain the way it's implemented and designed. But before that, let me explain why this architecture. In other words, why all the events are stored. Let me explain. As I said, there are so many partner companies with whom we have developed games. And for each of the partners, as well as depending on the games, the criteria or requirements for different functions will be different. Therefore, if we are too rigid, and then there might be some inconveniences because of the lack of flexibility for different games and different partners. Therefore, as a game platform for games and services, it's important that we keep flexibility in terms of design. And in the system this time, rather than having aggregation beforehand, it's important that the administrator actually sets the ranking-related criteria so that his or her desired ranking can be realized. So it is on a per-game basis, according to the preference of the administrator. Now, the data store, where the events are to be stored, let me just briefly go through some of our requirements, because there can be a lot of events in a very short span of time. Therefore, write efficiency has to be high, and also adding together or averaging, these simple calculations need to be received in the aggregation queries, and also according to the set intervals set by the administrator tool, the queries need to be aggregated. And in this particular case, the interval is 2 hours, and updating is done every 20 minutes. So from 12 noon, you get 10 10 a.m. to 12 noon, 2-hour worth of data, and the events are aggregated. And then 20 minutes later at 12 past noon, then you look at the day events from 10:20 to 12:20. And of course, maintenance cost has to be reduced. That's our desire as well. Now, the database that satisfies all of these requirements, you might know, is time series database, which is shortened as TSDB. And this time, we decided to use TSDB for event storage. Let me elaborate a little more on TSDB. Roughly speaking, this is optimized for data store in a time series. Now, leveraging the characteristics of the time series data, you compress data and enhance the writing capabilities, and also aggregation functions for the different data is the characteristic. And also, this is also used for sensor data aggregation in addition to log aggregation. And there are some logos on the right-hand side, open source, OSS, or for commercial applications. There are many products that are actually touting that they're using TSDB, and they have been released. Among them, our first idea was to use OpenTSDB, which is one kind of TSDB, and this used to be maintained by Yahoo in the US, and backend uses HBase, and the rest is Java. And our team was already using HBase for other components, as will be explained later. It's written in Java, therefore we thought there is high friendliness or affinity. However, at the end of the day, we decided that OpenTSDB might be a difficult choice to choose. The reason is this HBase version that we selected and OpenTSDB, when they were used in conjunction and applied some loads, there was a bug. And of course, we were able to apply a patch to avoid this negative impact. However, there was yet another negative element. The aggregation time window of OpenTSDB was fixed. For example, Unix epoch, you had to just use this fixed window that is in grids, and therefore we decided that that should not be the case. In other words, we decided to choose a different one, which is Elasticsearch. Elasticsearch, as you might know, is known for full text search. Engine log data store. It's an open source software. Within the team for logs and other applications, our team members were already using Elasticsearch, and therefore we could have a shorter learning curve. And infrastructure-wise, there were some clusters that had already been structured, and also there were other cases where Elasticsearch was used. Line Life ranking system also used Elasticsearch, and also if you can look at our engineers' presentation in YAPC Kansai 2017, which is a Pearl conference, you would understand better. And also in CHEP 2015, as well as in the paper by CERN in Europe, they talk about the OpenTSDB, InfluxDB, Elasticsearch in distributed systems, and they make a comparison among the three, and they concluded that Elasticsearch was the best TSDB. Let me just go back to the architectural diagram. Let me double-check again who the players are. The event handler, the storage that stores the events, and also the aggregator that aggregates the events from the storage. And we implemented them as follows. When an action arrives at the API, then API server publishes the message to Kafka, and then the event consumer will consume that. And actually, the event will be stored in Elasticsearch. And according to the prefixed setting by the administrator, the aggregator will query the Elasticsearch, and then aggregation will take place, and then the result will be stored in Radius, and API server will reference Radius, and ranking of the users will be given back as a response. And event is stored by handler, and we implemented this using Kafka and Java application, which is a consumer of the Kafka. And Kafka is used as the event queue, which is asynchronous. And we aggregate the event, and aggregation service that provides the response actually was using aggregator Java application and NoSQL radius. And the storage will actually set a query, and the result will be stored in the store set. Now, what we have to do is tuning. The performance has to be tuned, and also for the waiting, Elasticsearch side takes care of that. However, the addition portion, Java is actually taking care of that right now, but we're thinking that possibly we can have Elasticsearch handle that as well. So my part is now over. I'd like to hand over to Mr. Zhao about Guild.
Thank you, Kagaya-san. Hello, everyone. Thank you for coming. I'm Zhao from LangGame platform team. In the next 15 minutes, I'll talk about our HBase transaction processing system. Currently, in LangGame, our main storage is HBase. HBase supports single-row transaction processing. It's able to get several different cells from one row in one get operation. And for any put operation, it will either wholly succeed or wholly fail. HBase also provides a check and put API, which means it checks one cell's value. If it matches the expected value, it will add the specified put and return true. Otherwise, it will return false. HBase also provides the increment API. It increments one cell's value and return the result. But all these APIs are single-row transaction processing APIs. HBase doesn't support multi-row transaction processing. So why do we need a multi-row transaction processing system? And because it's too long to say, from here on out, I'll refer to the transaction processing system as TPS. So why do we need a multi-row TPS on HBase? Just as Kagaya-san said, we have a lot of new features, and one of them is Guild. Guild is an in-game community. It's created by in-game users. And one game can have many guilds in it. Users in one guild can chat together, can play game together. By joining a guild, users could feel more involved in the game. And many games provide a guild-like system. And on the other hand, guild system is always a complicated system. It costs a lot in game developing. So, in order to help game developers reduce developing time, we'd like to provide a full functional guild system on our game platform. To do that, we need a multi-row transaction processing system. Here, let's see a simplified guild join task. In this task, we let a user join a guild. Firstly, we get the guild and verify it. If the guild is full, we cannot let the user join. Then we get the user and check whether the user is already in any guild yet. If so, the user cannot join this guild. If all the verifications are passed, then we can put the user into the guild. Firstly, we increase the guild user number by 1, and then we update the user's information. Obviously, this is a transaction, and there are two different objects, guild and user. They are kept in different tables, different rows. So the TPS must be able to handle data from different tables and different rows. So why not use a relational database? A relational database like MySQL has powerful transaction processing ability. Just as Kagaya-san said, we have a lot of games in our platform, and our new games are released at a high rate. Sometimes multiple games are released in a very short time period. And it's really hard to tell which game will be hit. So our main storage must be scalable. In particular, our requirements for scalability are, first, zero downtime. And while the scaling, we need both more read and write capacity. And the scaling should be easy. The auto scaling is the best. So we decided to try to build a multi-row TPS on HBase. And actually, there are several open source TPS already exist. For example, Phoenix and Hansa. But taking into integration cost and the compatibility, we decided to build our own. Some of the open source TPS modify HBase itself, which means if you want to that, you have to restart the cluster. Even if you could restart the HBase daemon one by one, it's still a little risky. And some of the TPS adding special servers to control the transaction processing. That means small servers to maintain. And we are a small team, we don't want that. And there are two types of compatibility problems here. Firstly, the HBase version. We want the TPS to support exactly same version we are currently using. And secondly, in our game platform, we are also using some other storages and middlewares, like Redis and Kafka. And we have already made some tools to use them together. And we want the TPS to be part of them. So based on these considerations, we'd like to build our own. Here is our main spec. Firstly, it's based on the two-phase commits protocol. It provides a serializable isolation level. And now it supports HBase get and put operations. The integration is seamless. What we have to do is just import the Java library and add some tables and columns to the original database. Okay, for those who may not be familiar with 2PC protocol, I'd like to give a short introduction first. 2PC is a distribution algorithm. It coordinates all the processes participants in one transaction. And it separates a commission to a request phase and a commission phase. In request phase, coordinator, this green ball, will send a request to all the participants, these white balls. And the participants will take some steps and respond yes if it succeeds, no if it fails. After it responds yes, other coordinators' access will be blocked. And if any participant responds no, this transaction will be aborted. In commit phase, the coordinator will decide whether to do commit or do abort, and notifies participants of the results, and then the participants will do commit or do abort. Okay. Let's see how we apply 2PC to last guild join task on HBase. Here we have two tables, and let's assume our task is let user UA join guild GA. We can see the guild has 9 members in it. Let's assume it's not full. And the user's guild ID is empty. That means this user is not in any guild yet. And there is one additional status column in each table. It's added by our TPS. This status is composed of 3 values. The first one indicates whether this row is locked or not. The second one indicates which transaction locked it or not, or unlocked it. The third one is a timestamp, indicates when this row was last updated. When we get data from HBase, this status will be retrieved at the same time. And when we update the data in HBase, this row will be updated at the same time. Okay, let's see what happens before the commission. Here, let's assume the status GS1 green and US1 green are not locked status. That means we can access these 2 rows. Okay. Firstly, we get the guild and verify it, and then we get the user and verify it. If other verifications are passed, we put the user into the guild. We set the guild's user number to 10 and update the user's guild ID to GA. By now, all changes are still in application memory. Okay, let's see the request phase. All modules in this green box make one coordinator. Here is our application. And here is a global transaction ID generator table. It's used to generate a strictly increasing transaction ID. And here is a transaction status table. It's used to save transaction processing status and all the raw informations in one transaction. These two tables are created by our TPS. In processing, our application will first use HBase increment API to get a new transaction ID from this cell, and then put a record includes the initial status and all the raw informations to this table. Okay, we have two rows to update in this transaction. One guild row and one user row. In request phase, the coordinator will send requests to all the participants. Here, the request is a HBase check and put API call. For example, here, we check whether the status is still equal to GS1 green. If so, we put a new status, GS2 write, which is a locked status, and the new user number 10 to this row. From now on, this row's access will be blocked. Other coordinator cannot update it or read it. And please notice here, we set this cell's version to 2, just the same with the TID. This cell version is used to do rollback. If we want to roll back the updates, we can just delete this cell with this cell version. Okay, after we updated the guild table, a guild row and a user row, all changes are saved into HBase now. The guild's user number is 10 and the user's guild ID is GA. But all these rows are locked. Other coordinators could not visit it. Then we still use the HBase check and put API call to change the transaction status to finish the request phase. In commit phase, the coordinator will unlock all the rows. Here we still use the HBase check and put API call. For example, here we check whether the status is still equal to GS2 write. If so, we can put a new status, GS2 prime green, which is a not locked status. From now on, this row can be accessed by other coordinators. And after all the rows are unlocked, this transaction is finished. Okay, this is a full example of our transaction processing. At last, I want to talk about the limitations of using this TPS. We have two main limitations here. Firstly, as you may have noticed, we cannot use cell version in service anymore. It's used to do rollback, and it's used by our TPS. And now we are only support HBase put and get operations. We are not support other HBase operations. It's not very convenient in some situations. And now there are several games starting to integrate with our new game platform. We are now focusing on the performance tuning and bug fixing. And after that, we have to test this TPS on more versions of HBase. And we plan to support more HBase operations, like scan and delete. And you can see we are locking the entire row now. In future, we plan to just lock the HBase column family, I mean portion of row, to enhance the concurrency. In this section, we talk about our new game platform, and Kagaya-san talked about how we handle the time series data, and I talked about how we handle transaction data. If you have any questions, you could find us in the question corner. Thank you for coming and listening. Thank you.